Hi guys, in this video we will be learning theoretical probability. So first thing we have to understand what is theoretical probability. Probability of an event is calculated using of this formula. It's equal with the number of favorable outcomes divided by the total number of outcomes of that event. For example, when a coin is tossed, so a coin has two faces, head or tail. So it means that the total number of outcomes is 2, either head or tail. And the number of favorable outcomes, it depends. If you want to have a head, then the number of heads going to be your favorable outcome. If you want to have a tail, then the number of tails will be your favorable outcomes. If I toss a coin once, then the chance that I have a head is 1 out of, so for example, the probability of having a head is 1, which is my favorable number outcome is 1, and divided by the total outcomes is 2. So probability of having a head when you toss a coin once is 1 out of 2, theoretically. If you don't want to have a head and you want to have a tail, then your probability of having a tail equal with the number of favorable outcome. So a coin has 1 tail, so it's equal 1 divided by the total number of outcomes, which is 2. Then probability of having a tail is also 1/2. Okay, that's why we have this one. So let's check out with the next example to see, to understand more about theoretical probability. A die is rolled and the number upmost is noted. Determine the probability of each of the following event. Event A is I want to have the face that have 1 dot. As you can see here, this one is the fair die. A fair die has 6 faces. The face that have 1 dot, the face that have 2 dots, or 3 dots, 4 dots, 5 dots, or 6 dots. Just make it like 5 dots, gonna be like this. Okay, just for example. So I want to have event A, I want to have the face that have 1 dot, which is this one. Okay. So probability of event A theoretically will equal with the number of favorable outcomes divided by the total of outcomes. A dice has 6 faces, so the total number of outcomes here is 6. And I want to have the face that have 1 dot, and it's only have 1 face that have 1 dot in here. So my favorable outcome here is 1. So the probability of event A that having a face that have 1 dot is 1 out of 6. It is theoretically. Okay. Now event B, and my favorable outcome in event B is having odd numbers. So probability of event B equals with the favorable outcomes divided by the total number of outcomes. And we know that the total number of outcomes is 6 faces. It not change, never change. And odd number, so this one we have to, odd number is going to be 1, 3, or 5. So this one is odd number, 1, 3, or 5. Okay. So rolling a dice, we will have 3 odd number, 1, 3, or 5. So it means my favorable outcome here is 3. So the probability of having odd number is 3 out of 6. And remember that we always have to simplify our fractions. So simplify with 3 is turned to 1/2. C, probability of having a 4 or a 6. Okay, so look at this one. This one is 4, this one is 6. So it means that our favorable outcome here, just write down probability of event C that having 4 or 6, and always the total outcomes never change, which is 6 faces. And I want to have the face that have 4 dots or 6 dots, so it means 2 faces, so it's equal with 2 out of 6. Simplify these fractions is equal with 1 out of 3. Okay. Now we're going to move on to the next example. A letter is selected randomly from the word watching. State the number of possible outcomes. So you can see here, this one we have how many words? Okay. How many letter? 1, 2, 3, 4, 5, 6, 7, 8. So the number of possible outcome is 8. What is the probability of selecting a T? So we're going to write down probability of having a T equal with the favorable outcomes divided by the total of the number of total outcomes. And we know that the number of total outcomes is 8. Write that down here. What is the number of your favorable outcomes? So in this letter, in this word, how many letter T? We've had only one letter T. So your favorable outcome is 1. Okay. So the probability of having a T is 1 over 8. What is the probability of selecting a vowel? So we know that we have only 5 vowels: A, E, I, O, or U. So we count in this letter, watching, how many vowels? It is A, is I, only 2 vowels. So the probability of having vowel, it's just like letter V, equal with the number of favorable outcome, which is A or I, A and I. So it's 2, and the total outcomes is 8. And again, we always simplify our fraction to the simplest form, which is 1 out of 4.